Hi everybody, welcome to SBS 304 Research Methods. Obviously, this video is super late. It's late Tuesday night and I'm just now getting it to you. This deserves an apology. I'm very sorry that I'm so far behind. Remember how I've been saying the whole semester, the world is on fire and we're more than our productivity. I hope you will extend that same kind of grace to me this week, as I have gotten pretty behind with some work. So I'm trying to catch up now, and I hope that we'll all be back on track by Thursday. So I don't expect that anyone will have participated in the lecture discussion this week. I'm just going to give everyone full points for that. So don't worry about your grade and how this will affect you. Just try to watch the lecture and then participate in the reading discussion. So this should be a pretty short lecture. Talking about experiments, and I'm just going to dive right in. So the real value of experimental research for sociologists is that it makes it possible to establish causality. Remember how we've talked about before that with survey research, it's necessary to have longitudinal data to establish causality. The reason for that is that we have to be able to establish temporal priority and establish logical priority in order to establish causality. Well, when we have experimental research, that's built into the design. So we're able to link variables in causal ways. So we're able to do this by manipulating the independent variable and then measuring the dependent variable. And we're able to know that the manipulation of the independent variable is causing is causing changes in the measurement of the dependent variable for a few reasons. First, we randomly assign participants to conditions. So one condition would be the experimental condition in which the participant receives an intervention or experiences a stimulus. The control condition in which otherwise similar participants randomly assigned don't get the intervention or get what we call a placebo intervention, meaning they get something but not the variable under study. We'll talk more about examples in a moment. Finally, researchers are able to hold other factors constant. So we'll talk about that in a minute, but it relates to the idea of spuriousness. The idea that perhaps some feature of the participants themselves or some other factor not under study is causing the relationship between the variables. So some advantages of experimental research are that it helps us to establish causality. It can help us to uncover mechanisms for why a phenomenon takes place. And it can help us to test abstract theories and get to the bottom of pretty complex relationships. So in order to establish causality, X and Y must be correlated. In other words, if X goes up, something has to happen to Y. Either it goes up or down according to changes in X. Here, X is an independent variable and Y is a dependent variable. X has to occur in time before Y. So it doesn't make sense to say that X causes Y if Y happens before X happens. And finally, X and Y must not be caused by a third factor. So an example of this would be if something about the conditions the participants lived under caused them to do Y instead of X causing them to do Y. So we'll give some examples of external factors that can be controlled later. But experiments allow us to ensure that X and Y are correlated, that X occurs in time before Y, and that X and Y are not caused by a third factor. That's because we can hold third factors or other factors constant. meaning we can make sure they're the same for all participants. We can do this either by selecting participants that are similar in important ways, ways relevant to the study, or by manipulating other variables such that they're the same for everybody. I'll give you an example in a moment. Experiments can allow us to uncover mechanisms of how things work. So by manipulating the independent variable, we can often determine how it affects the dependent variable. And a really good example of a lab experiment done in the social sciences is the stereotype threat experiments done by Claude Steele. So how many of you have ever had the feeling when taking a test or an assessment or an evaluation that if I do poorly at this, it's not just that people will think I'm bad at this. Maybe people will think that people like me are bad at this. Maybe it will reflect poorly, not just on me as an individual, but on some group that I belong to. Well, Claude Steele had this insight that this could be true for particularly women and racial and ethnic minorities, that these folks may be concerned whenever they undertake an evaluation task, like an exam or a standardized test, that if they fail, they're not just letting themselves down, they're letting their group down. That they would, because of stereotypes about their group, reinforce those stereotypes. So what Claude Steele did was he started with math tests. He knew that women had been told that we were worse at math. So he recruited a bunch of math majors from a university. Now, why recruit math majors? Well, they're all good at math. They're all presumably not only competent at math, but willing to work hard at math. So he recruited a bunch of math majors, and he randomly assigned them to the experiment group and the control group. And here the independent variable is awareness of stereotype threat. So the control group, the group not getting an intervention or a stimulus, were told that they were helping to validate a new kind of math test. The experimental group, the group receiving the intervention or stimulus, was told that they were being given a test of their math ability. So if you're told that people like you are bad at math, and then you're told that you're taking a test of your math ability, you're primed to think that you might be bad at this test. But if you're told that you're validating an instrument, well, there are no stereotypes about who's better at validating instruments. So perhaps you wouldn't have the same awareness of stereotype threat. So these are different levels of the independent variable: awareness of the threat or lack of awareness of the threat. And what Claude Steele found was that among the group told that they were validating an instrument, there were no differences between men and women's performance on the math test. But between groups told that they were taking a math test, there were noticeable differences. Men outperformed women significantly. So this supported his hypothesis that awareness of stereotypes about women and math made women perform worse on the test. He then did the same thing with IQ tests and white students versus students of color. Half of white students and half of students of color were assigned to the control group and half to the experimental group. And again, the half in the control group were told that they were helping to validate a new test. Those in the experimental group were told that they were taking an IQ test. And again, in the control group, there were no differences between white students and students of color. But in the experimental group, white students considerably outperformed students of color. further supporting Claude Steele's hypothesis that awareness of stereotypes about marginalized groups made members of those groups perform worse. So, this is also a good example of how experimental research can be used to test abstract theories. So, by controlling for confounding variables, we can test the relationships among independent and dependent variables in a much more clear and concrete way. So, the idea that being aware that you're part of a stereotyped group and that could hurt your ability to perform is a very complex idea. It's a very abstract and kind of squishy theory. But by controlling for other things like how good a person is at math, or whether a person is confident about doing math, or whether a person is aware that they're a member of a stereotyped group, by controlling those confounding variables, we can test the relationship between the independent and dependent variables in a clear way. Now we're going to talk about some types of experiments, including laboratory experiments, field experiments, survey experiments, and natural experiments. So the type of experiment you're probably most familiar with are laboratory experiments. Laboratory experiments are great because they have really high internal validity. In a well-controlled experiment, we can effectively evaluate causal relationships, which is the standard for internal validity. However, laboratory experiments also have low external validity because the conditions of an experiment in a laboratory are so artificial that it's really difficult to know how those results would generalize to everyday life. So, it's a trade-off with a laboratory experiment. You can really carefully investigate and effectively investigate causal relationships, but you can't really generalize your findings very well. Field experiments are experiments that take place in the real world rather than in a laboratory or an artificial setting. The independent variable is still manipulated, and random assignment to conditions is still practiced. However, confounding variables cannot be controlled. An example of a field experiment would be asking people in a school to take different versions of the same test to see if the way the test was worded made a difference in how people performed. So the people could still be randomly assigned to conditions, and the independent variable, which version of the test people took, would still be manipulated. But confounding variables, such as whether students had eaten breakfast that morning, or whether students, took the test early in the day or late in the day, wouldn't be controlled. Survey experiments are more commonly done in social science, and it's when participants are randomly assigned to receive different survey questions, where in this case, the survey question itself is the independent variable that's being manipulated. So if the survey is being given to a large and representative sample, researchers can then make between-group comparisons between those who received one version of the question and those who received another version of the question. So an example of this is people who are given vignette studies. So I study mental health and mental illness. There was a popular vignette study where people were given vignettes. A vignette is like a character sketch or a description of a person, usually fictional, meant to represent particular characteristics. In this case, different kinds of mental states. So this experiment was done in 1990 when mental health was not really discussed very much and was highly stigmatized. So participants were shown vignettes or descriptions of a person with schizophrenia, a person with obsessive compulsive disorder, a person with very severe depression, and a person with what we would call subclinical bad mood, meaning their mood was bad. They weren't having a good time, but they weren't mentally ill. They were just having some problems. Well, in 1990, it turns out that most people correctly identified the vignette of the person who just had some problems. Unfortunately, they also incorrectly identified most of the mentally ill vignettes as just having some problems and not being mentally ill. So they were more likely to ignore clear and obvious symptoms of mental illness and say, that person's just having a hard time right now, but they're okay. Well, the experiment was repeated in 2010 when mental health discourses had really changed. It's 20 years later, and people are really talking about mental health and mental illness by 2010. And researchers suspected that if the study were repeated, participants would be more likely to correctly identify mental illness. Well, it turns out not only did they correctly identify mental illness very frequently, the vast majority of the time they said this person should get clinical help, they're having symptoms of a mental illness. They also incorrectly identified that the person having a bad mood or a bad experience was in need of clinical help for a mental illness. So in fact, people were overdiagnosing mental illness. So this is a survey experiment. People were randomly assigned to receive either the clinical vignettes, that is the vignettes of mentally ill people, or the neutral vignettes, the vignettes of people just experiencing bad mood. And here the independent variable, though, was time. The independent variable was when they took the survey. Did people in 1990 answer the survey differently than people in 2010? So the vignette study stayed the same, but the year changed. So in this case, time is the manipulated independent variable. This is an example of a survey experiment because it was done in a survey form rather than a laboratory or the field. In natural experiments, researchers don't directly assign participants to conditions or manipulate the independent variable. Rather, researchers collect and analyze data from those who receive an intervention and those who don't. An example of this is the Move to Opportunity study. The reason social scientists generally don't do experiments is because of the things we study. We study social structures and social inequality and social resources and political, actions and policies. It would be either impossible or highly unethical to manipulate those experiments. So I'm going to give you, or to manipulate those variables, because we would be materially helping some people and harming others. So I'm going to give you two examples of social science experiments that have been done and assessed by social scientists. So one was called the Move to Opportunity study. We know that students who grow up in high poverty neighborhoods tend to do less well in education and in other markers of well-being like self-esteem and confidence. So, however, it's impossible for us to simply say, we're going to take 1,000 children and we're going to assign half of them to live in concentrated poverty, and we're going to assign half of them to live in a nice house in the suburbs. We can't do that, and even if we could, it would be horrible. So instead, the city of Chicago decided to do exactly that. They decided to randomly select a number of people from a pool of applicants to receive vouchers to move from concentrated poverty conditions in the inner city to a nice house in the suburbs. Now, it was random assignment to conditions because it was the vouchers were given out by a lottery, and there wasn't the confounding variables of motivation or desire for improvement were controlled because the only people selected were applicants. Everyone who was selected from a pool of people who had applied for the program. The control group, incidentally, was made up of people who applied for the program and weren't selected. So they had the same level of motivation, the same desire to participate in the Move to Opportunity program, but they weren't chosen. So if researchers had designed this project, it would have been very unethical because we would have been giving a material good to some people and withholding it from others. What we did instead, by we I mean social scientists, not me myself. I wasn't there. What social scientists did instead was design questionnaires and design metrics to measure outcomes for people who were given the vouchers versus people who weren't. This was a sort of natural experiment. Another example of a natural experiment is the healthy immigrant hypothesis and the effects of racism on birth outcomes for Black mothers in the United States. So, Black mothers in the United States are much more likely than white mothers to experience negative birth outcomes. This includes low birth weight babies, sick babies, babies who die, and mothers dying in childbirth or around childbirth. So, Black women are much more likely than white women to experience these conditions. And for a long time, it was believed that this had something to do with genetics or predisposition or something of the kind, or with generational trauma. That Black women in the United States had been so traumatized over generations by things like slavery and Jim Crow segregation and lynching that it had somehow made its way into their bodies, causing them to have worse health and worse birth outcomes. So some public health officials thought that this didn't sound right, that this idea of generational trauma wasn't necessary, and that this idea of genetic worse health was nonsense. So they devised kind of a natural experiment. What they needed for this experiment was women with similar genetic backgrounds to Black American women, and no experience of being Black in the United States. Essentially, they needed people with similar genetics who weren't American. So they found a population of African immigrant women to the United States. They're women who had moved to the United States who were of African descent, but who were not African American. And so they measured birth outcomes for these two groups, and what they found was that while Black women in America were consistently worse off than white women in America, African immigrants to America had no differences with white women. They were indistinguishable from white mothers in their birth outcomes. So then they followed up. After a generation of living in the United States, the daughters of African immigrant women had indistinguishable birth outcomes compared with Black women. So what this tells us is two things. First, that genetics isn't an explanation. If there were something about African ancestry or African descent that created worse birth outcomes, you would expect African women to have it even more than Black American women, perhaps, or at least to the same degree. And if it were generational trauma, you would expect that women who didn't experience this generational trauma, that is, the daughters of immigrant women, would exhibit similar outcomes to white women. But that's not true either. Within one generation of living in the United States, the daughters of African immigrants had the same kinds of birth outcomes as Black American women whose family had been here for generations. So what the researchers concluded was that there's something about the day-to-day reality of being a Black woman in America that causes worse health and worse birth outcomes. That being a Black woman in America is literally just so stressful that within one generation, it harms your health and your ability to bear healthy children. So it isn't genetics and it isn't generational trauma. It's day-to-day trauma. It's everyday experiences of racism that are creating these outcomes. So we can't really talk about how to design natural experiments because they kind of come along every now and then, and we can go with them. We can't really design or control them. And the principles of designing a laboratory experiment can be easily applied to different kinds of experiments as well. So that's what we're going to talk about today. So first, you need to set the scene for your laboratory experiment. When you've recruited participants and assigned them to conditions, you need to first avoid revealing your research hypothesis to participants. In order to keep them engaged, you need to give them some plausible alternative reason to participate. Now, why do you want to avoid revealing your research hypothesis? Generally because people are very cooperative, especially if they've agreed to help you. If they've agreed to participate in your study, they often want to be helpful, and they think that confirming your hypothesis is helpful to you. So they're less likely to behave in ways that might be authentic to them if they think it will disconfirm your hypothesis. So to keep participants engaged, you want to give them a plausible alternative reason why they're participating. Notice that in the Claude Steele experiment, the stereotype thread experiment, participants were told that they were taking a test, or they were told that they were validating a testing instrument. They weren't told that they were assessing how well people of color or how well women did on tests. They were told what to do, but they weren't told why they were doing it. However, we want to avoid harmful deception. We don't want to, just because we're misleading participants slightly about the aims of the experiment, this doesn't give us kind of a blank slate to do really unethical things and trick them about the nature of the experiment, how their data will be used, or what they'll be asked to do. This would be unethical and unjust. So there are a couple of ways, once participants are assigned to conditions and the setting is created, that we can manipulate the independent variable. This includes between subject design, where participants are chosen at random to receive different levels of the independent variable, and then researchers make between group comparisons. An example of this could be people taking the survey at different times. People taking a survey at different times. So people who take test in the morning versus people who take a test in the evening. Or within subject designs, where all participants receive all levels of the independent variable, and then we compare participants' behavior under different conditions. So in this case, we might have all participants do a test in the morning and then do the same test again in the evening and compare how they did in the morning to how they did in the evening. We also have a few different ways that we can measure our dependent variable. In order to understand how the independent variable affects the dependent variable, we have to make effective and careful measurements of the dependent variable. So we can use a few different kinds of measures. We can use behavioral measures, observations of overt behavior. This can be really useful because overt behaviors are more difficult to fake. People can lie about their opinions, their beliefs, etc. But if you ask them to do something, it's difficult for them to fake or dissemble that. An example are implicit bias studies, where people are given basically association tasks, where they're asked to quickly group characteristics with groups of people. It's difficult to fake being able to do that. And attitudinal measures, which are self-reports of feelings, beliefs, opinions, etc. Attitudinal measures are especially susceptible to social desirability bias, which is the tendency of participants to express views that they think will make them look better. Most of us are aware that when we're asked about things like racism or sexism or homophobia, that there are kind of correct answers. We may even sense in a particular political climate that there's a right answer on political belief questions or political opinion questions. And we may be more likely to give answers that we think will make us look more favorable to researchers. So, attitudinal measures, it's especially easy to give these kind of desirable responses. And finally, we have physiological measures, which are observations of body states. So, for example, if I wanted to know how much a person was stressed by being asked to take a math test, I could measure their blood pressure, or I could measure their pulse, their heart rate, how fast their heart was beating. I could also, if I really wanted to go deep, measure their level of cortisol in their blood. So there are physiological measures I can take too. Some good things about those, they're impossible to fake. Some bad things, they're really invasive. So those are the kinds of measurements of the dependent variable I can use. Finally, after the experiment is complete, I want to debrief my participants. That is, I want to chat with them. I want to tell them what's going on and ask them how they feel. I want to tell my participants the real goals of the study, so they leave understanding what they had actually been asked to do. I want to answer any questions my participants might have and address their concerns. I may want to provide additional resources. Depending on what my study was on, I may want to refer participants to counseling resources or to resources to help them with a problem they may be experiencing. And finally, I can interview participants about the experiment to assess the experiment itself. I can say, hey, when you were doing the experiment, what did you think it was about? Or tell me, when I asked you this question, how did you feel about that? So that's the debriefing process. This is all I really want to tell you about experimental research today. I hope this has been helpful. If you have questions, please get in touch with me and let me know. Stand by for a brief video explaining lab exercise 4. Everyone have a good week.